Okay, and this is where we finished off last lesson. Now, we're now going to talk about what simple harmonic motion is using formulas now. So, simple harmonic motion occurs when a particle moves backwards and forwards. I think we wrote this yesterday. Simple harmonic motion occurs when a particle moves backwards and forwards, it will be in a straight line, in such a way that the acceleration is proportional to the displacement from a fixed point O, which is our origin, all right? Now, no, that. So therefore we can say that A equals negative K times X. Now, why am I saying that A equals negative K times X? The reason I'm saying that is that if you look back at the table that we did yesterday or at your graphs, when X is positive, acceleration is negative. And when X is negative, acceleration is positive. So here's the table that we did last lesson. For example, here when X is 5, can you see that acceleration is negative 80? When X is, don't worry about the zeros, it won't work there because 0, well it does work, but you can't see it. But when X is negative, negative 5, acceleration is positive. Can you see that? It's positive 80. Negative 5 times 16, times negative 16, for example, is 80. Look, 5 times negative 16 is negative 80. Negative 5 times negative 16 is 80. Can you see that? So acceleration is some negative constant times x. That's what we mean by that the particle moves backwards and forwards in such a way that the acceleration is proportional to the displacement. So that's the acceleration, that's the displacement. We can take the displacement, multiply it by a number and get the acceleration. Okay? Now, it's A equals negative K times X because you've got to multiply X by a negative number to get the A. Do you see that? Now, since when X is positive, A is negative, and when X is negative, A is positive. That's why A equals negative K times X. Now, for ease of calculations, this is what we do. For ease of calculations, we use K equals N squared. You know how in our example, K was 16? It was 16. Because 5 times 16 gave me 80. Or 5 times negative 16 gave me 80. So we use K is N squared. Therefore, we've got this formula that A equals negative N squared X. Now this, you have to know this formula.
It's on our formula sheet.
Great. And it's on the...
It's X
now,
minus B.
Or X double dot is equal to negative N squared X.
The formula says minus X.
This is the simplest form of the equation where the centre of the motion is at the origin. But with simple harmonic motion, centre of motion is not always at the origin. We're just looking at the most basic case at the moment, okay? The equations. Now, if we look at the centre of motion is the origin, if the centre of motion is the origin, we're going to derive the equations for that. So, we were looking at an example. We're just going to take the cos curve. X equals A cos NT. We were doing 5 cos 4t, I think. That's what we did. But the equations will be of this form. We're going to start with the cos curve, not the sine curve. Remember, sine curve is cos curve shifted or vice versa, but we're going to start from the highest point. We're not going to start from the origin. If we take the sine curve, we're starting from the origin. If we take the cos curve, we're starting from the extremity of motion. Okay? So, centre of motion is at the origin. We've got X equals A cos NT. If you differentiate that, X... Right, because simple harmonic motion is a particle moving forwards and backwards or up and down. When you sketch that against time, you will get a cosine curve or a sine curve. Okay? Because what will happen is the particle will be the same distance. You know how we were doing these last lesson? All right, I'm going to start, because it will follow that shape. If you go with time, So if this is x, its position, and this is its time, then the, just one sec. Okay, period will be 2 pi on n. Okay, so the period here will be 2 pi on, depending on what n is. Okay, if n is 2 or 1, it'll be 2 pi. If n is 2, it'll be 2 pi on 2, which is pi. So the period is 2 pi on n. Okay, so if x equals a cos nt, tell me what velocity, which is x dot, is. Differentiate. Differentiate cos, you get negative sine. So it's a times negative sine nt times, differentiate the nt, you get n. So it's negative an sine nt. That's what x dot or v is. Are we okay with that? Now, what I'm going to do, I'm going to square that. So v squared, I'm going to derive this equation here. That's what I'm trying to do. Okay? I'm going to derive that acceleration is negative n squared x. Now, this is a really, really important derivation of a formula. So v squared will be what, guys? Square that now. What do you get? Won't it be negative an sine nt squared, which is what? Square the negative, you get a positive. A squared, n squared, sine squared nt. Now, a squared, n squared, how do you write sine nt squared? You write it as sine squared nt. You don't square the nt. That is sine nt times sine nt.
But why did you square the v?
Oh, because I'm going to derive this. I'll just show you in a minute. So that is a squared n squared. I'm trying to derive something for you. All right? All right, you know how we know that sine squared plus cos squared is 1? I'm going to write this as 1 minus cos squared nt. Just follow it. You don't have to know why I'm doing it yet. Just can you follow what I'm doing?
Yeah.
All right? Which is a squared n squared. Now, what does x, you know how cos nt, x equals a cos nt? So just over here, x equals a cos nt, therefore x on a equals cos nt. So I'm trying to get it back in terms of x. What I'm trying to do here, I'm going to start with that and I'm going to try and get acceleration is negative n squared x. That's what I'm trying to do. So I'm trying to derive that from this. So I've started with x. I've done v. I've done v squared. And I've got, now why am I squaring? Probably because I've got this n squared. That's why I'm squaring, all right? So I've got v squared is that. I need to get it back into the original x. So I'm changing sine squared nt into 1 minus cos squared nt. Because why? Because sine squared x plus cos squared x is 1. Now, I know I need to change this cos squared nt into x's and a's. I know from the original equation that x equals a cos nt, so x divided by a is cos nt. So what does cos squared nt equal? Just square both of those. What can I write? X squared on a squared. Now multiplying each term.
What happened on negative?
When you square a negative,
Yeah, that's what I thought. I was thinking.
yeah. Now multiplying a squared n squared by both of those, I get a squared n squared minus, if you multiply that by 1, you get a squared n squared. Multiply a squared n squared by x squared on a squared, what do I get? N squared x squared, which is equal to a squared bracket, no, it's not a squared, n squared bracket, that's an n, 1 sec. So taking out n squared as a common factor, v squared equals n squared a squared minus x squared. Since v squared has to be positive, because if you square something, you get a positive answer, therefore we can say that n squared times a squared minus x squared, sorry, v squared can be positive or 0, can't be negative. So since v squared is greater than or equal to 0, then n squared bracket a squared minus x squared is greater than or equal to 0 as well. Now, n is just a number, so I'm going to divide both sides by n squared. Therefore, we can say that a squared minus x squared has to be greater than or equal to 0. One sec. You might say, but n squared can be negative, but it can't be negative. N squared is positive. Because n squared is positive, therefore, instead of dividing by n squared, because n squared is positive, therefore a squared minus x squared has got to be positive as well. That's what I should have said. So therefore, a squared minus x squared is positive. Now what I'm going to do, you know that to do a question with a quadratic and an inequality, you must factorize. So a minus x times a plus x is greater than or equal to 0, which means that, how would you sketch that? Isn't that a concave what? Pretend a is the number, x is the x, a is a number, concave what? Down, lying between a and negative a. Where is this graph greater than or equal to 0? The solution is that x will lie between negative a and a. So therefore, it says the displacement, so therefore we can say that the displacement oscillates between negative a and a. Now, coming back from here, I'm just going to come across here for a sec. Just in a little box here. Have you got that? So therefore the displacement oscillates between negative a and a. You know how we've got, I've still not finished, okay? Now, have you got that? All right, let's just come back up here. We know that velocity is here, negative a n sine nt. I just went back to this result here. Velocity is negative a n sine nt, so therefore acceleration is, differentiating that, negative a n times cos nt times n, which is negative a n squared cos nt. That's what acceleration is. Now we know that, what does x equal? Look up the top. Now that x equals a cos nt, I can say that that's negative n squared a cos nt. You're probably thinking, Miss, why did you do this? I should have done this last. So that's okay. So therefore a is negative n squared x. So that's proving this. Sorry. That. All right. You're probably thinking, what have I done? I've done a few things here. So we've just proven that a is negative n squared x. So I could have just done that straight from here. So I've taken two paths. I've done this path and I've done this path. So if I would have continued from there, I can prove that rule. Or if I square it, see this result here? This is another really important result for simple harmonic motion. So there are a few things that we need to, there are two rules that you need to know. The first one is that, and the second one is this. We've derived the other one. V squared is n squared, a squared minus x squared. Wait.
So is that one of the equations?
Yes, this one too. Well, you'll recognise it. You'll more than likely have to derive that. So you'll have to be able to derive that. So that's why I've done it. Look, we're still going to do lots of examples. We're still just going through theory. But you can see how we've derived this result. So if you're ever asked to derive that result, you go x, v, differentiate again, and you can get a. I shouldn't have sidetracked, I'm sorry. Then if you're asked to derive this sort of result, you go x, v, v squared, do some substitutions, and you'll get this result. And then from there, you can see where your period, where your oscillation will happen between. Okay? But we know this anyway. We know that the displacement oscillates between negative a and a just from the equation, because that's the amplitude. So this is proving basically that the amplitude is negative a to is a units. In other words, it oscillates from negative a to a. But we've just proven two important results, and that's that result. acceleration is negative n squared x. And the other result that you sometimes have to prove is this one, that v squared is n squared a squared minus x squared. So you'll have to prove that sometimes as well. So we've just proven both those results. Do you have this all or not? Just continue. So therefore, a description of the motion. Now, this is for this, x equals a cos nt, okay? Again, we know that the particle, you're going to fill in the gap. So the particle, we know all that. I won't do that. I'll just talk about it. Don't write it. We know that the particle begins at A. Okay, it moves towards the center. This is the motion. I'm just going to draw it. Okay, this is what happens. The particle starts at A, so I'm not going to write it down. Moves towards the center. Is it speeding up when it goes towards the center? Yes. Yep, with increasing speed. It passes through the origin, then it moves to x is negative a. Is it slowing down or speeding up as it goes out there? Slowing down. It stops, it changes direction and moves back to O with increasing speed, passes O, decreases the speed to get back to A and so on. All right, this is what we're going to describe. X lies between which values? X, the displacement. All right, that's number one. It actually equals A too. Number two, tell me when velocity equals 0. When does it stop? So x equals 0 when, velocity equals 0 when x equals plus or minus a. Are we okay? So girls, this is what we're saying. Describing the motion, we've talked about this before as well. That the particle displacement is between negative a and a. It stops, the velocity is 0 at the extremities at x equals a and negative a. When do we have maximum speed but? So maximum speed is when, where? When x is 0. Now let me bring, we've got the x equation here. X is a cos nt. I'm going to write down the v equation, negative a n sine nt. So maximum speed when x is 0. You know, if I drew the x graph and the v graph, you can actually see the maximum speed here. Watch what I'm doing. This is a. This is the velocity. This is the equation for x. Got it? Can you see that? That's the x equation here. I'll just move this. This is the velocity equation. Oops. All right. Sorry. Yeah, we're always doing cos. Don't think so. All right, there's your displacement curve. You know how we differentiated displacement and got velocity? Tell me what this curve looks like, girls. Negative sine graph. Not like that. And give me the amplitude, please. Yep. Good. So therefore, tell me what maximum speed is going to be. AN. So, girls, the particle from the x graph, just watching, goes between a and negative a. Velocity is 0, and you can tell by gradient that when you're at a and negative a, velocity is 0, but you can see it down here as well. Velocity 0 on the ends. Maximum speed, look at the velocity graph. You can see the maximum speed. Now it's saying not maximum velocity, maximum speed, so we look at that position and that position. It's the amplitude. So therefore, maximum speed is AN. Are we okay with that? Okay. What's maximum acceleration? So maximum acceleration, I'm going to draw the acceleration curve, equals something when x equals, I'm just going to draw the acceleration curve and write down what it is. A equals, I've got it, negative n squared a cos nt. If I draw that, it looks like this. How does that look? It's what sort of cos curve? It's a negative cos curve. That's that curve. Can you give me the amplitude? N squared what? A. So, girls, displacement between A and negative A. Velocity 0 at the endpoints. Maximum speed is AN. But you can see it from the maxima of the velocity graph. And maximum acceleration will be N squared A. And that will happen when? When x equals what? Well, here it is, and there it is, and there it is. It's when x is what? When x is what? See this point? Corresponds to x is A. Do you see that? When x is plus or minus A. This point is this one, when x is minus A. So maximum acceleration, guys, is on the ends, remember? Maximum acceleration occurs at the endpoints of your swing. Remember, acceleration is 0 in the middle? Okay? It occurs, it is n squared A, but it occurs when x is at the endpoints. That's all we say.
You see number 3, max speed and x equals 0, maximum speed equals AN.
That's right, because look here, there's the velocity curve. Velocity is negative AN sine NT. If you draw it, the maximum speed will be at the top or bottom of this graph. Speed. No, its speed is irrespective of direction. If it's velocity, I'd put A plus AN. Yep. Yes, up. The acceleration at this point is n squared A. The acceleration here is negative n squared A. The magnitude is the same, but this is just acting to the right, and this is acting to the left. This is acting to the left as well. Same, yes, same maximum acceleration, but to the left. To show that motion is simple harmonic, is SHM, it is necessary to show that acceleration, now this is a really important point, you'd want to be boxing this one up. It is necessary to show that acceleration is proportional to displacement. That is, we want to show that x double dot equals negative n squared x. That's what you need to show. If we say show that it's simple harmonic motion, that's what you've got to prove. Now, that was in simple harmonic motion when the center of motion is not at the origin. So simple harmonic motion, we're looking at equations. Simple harmonic motion when the center of motion is not at the origin. So the formula, instead of being x equals a cos nt, we have a shift, a cos nt plus alpha. Do you remember this? We learned how to...
Maybe write it as B because that's what it's on our formula sheet.
It says B?
I'm pretty sure it says B. Let me write.
Simple harmonic motion when the center of motion is not at the origin, it's x equals a cos nt plus alpha. What do you think this plus B is? That's the up and down shift. What's the plus alpha? The sideways shift. So it's going to be plus B. Now, just leave that there at the moment. The B is so notice the B is the up and down shift. And the alpha is so that's the vertical shift. Is the horizontal or the sideways shift? Now the up and down one's the easiest one to work out. Now, so when we've got this equation, we know that A n, alpha, and b are constants. Type of curve, if we start from the top, A will be positive, N is going to be positive, A is the amplitude, or A affects the amplitude, N affects what? The period. And alpha moves, and I've written that, it's the sideways shift, but moves the graph across. So, and we know that B is the up and down shift. Sorry, I've written it there, but I'll just put B moves graph up and down. I already wrote that. Okay? Now, guys, when t equals 0, so when t equals 0, x equals a cos what? When t is 0, what have you got? X equals a cos alpha. I'm going to put the plus b here on the side, plus that constant. And the motion does not begin at A. The only way that the motion will start from here, like that, is if alpha is 0. Does that make sense? Because alpha is the sideways shift. So this will only be when alpha is 0. Otherwise, there's going to be a sideways shift. So the motion does not begin at A unless alpha equals 0. Yeah, unless alpha is 0 and b is 0. That's right. So we know that x equals a cos nt plus alpha plus b. So we're going to differentiate. So we're going to come up with our equations again. You know how we did our x, v, a, and our v squared is n squared, x squared minus a squared? We're going to do the same thing here for this equation. So we've got a equals that. What does v equal? Do you know what v equals? It's a times negative sine nt plus alpha times, differentiate the inside. What do you get? Alpha's a constant, remember? Times n. So it's negative an sine nt plus alpha. When you differentiate your b, you get 0. It's a constant. So that's what velocity is. That's what we had before. The only difference is the plus alpha. And I'm going to quickly do what acceleration is. X double dot is negative an. Differentiate sine, you get cos nt plus alpha times what? N. So acceleration is negative an squared cos nt plus alpha, which happens to be, acceleration is, so what I've got over here, I'm just going to do a bit of working out. X equals a cos nt plus alpha plus b. Therefore, x minus b equals, can I do x minus b? Yep, equals a cos nt plus alpha. We okay with that? I've just taken the original equation and gone x minus b. Therefore, if I want to substitute a cos nt plus alpha, a cos nt plus alpha, it's negative n squared x. Got a bit of a, wait, let me rearrange this. I don't like doing that. So isn't that negative n squared a cos nt plus alpha? Is that okay? I've just swapped that around. So now I get negative n squared bracket. What do I write? Good. X minus b. Now, here, that's what we've just derived. Got it? Just be careful there, please, that I would swap around the n squared with the a, then do the substitution for the a cos nt plus alpha, which needs brackets x minus b.
Code element half runner, element